Let's get down this question of the triangle. So we've got triangle X, Y, Z, but I've got an angle of 30 degrees, Y, X, Z. So let me draw it like that. So this X 30. So then XY is root 3A and YZ is A. And we want to investigate the area. Now it's already saying there's, for a given value of A, there are two distinct fun triangles. So this is not the only triangle, the one I've drawn, but let's investigate it. I've got an angle side pair, and what this is heading towards is the ambiguous case of the sine rule, where you apply the sine rule, you can actually get two different angles for Z. So I will write down sine 30 divided by A is equal to sine Z divided by root 3A. Well, I can cancel out the A's. Also, sine 30 is just a half, which means sine Z is root 3 over 2. And therefore Z is equal to 60 degrees. That is one exact value from root 3 over 2. So 30 gives a half, 60 gives root 3 over 2. But we're not done because there's another angle. We've got this one, it's 180 minus 60, so 120. Actually, that is the one I've drawn. That is the first angle. And therefore, let me think about my second diagram. Let me just take my first diagram. I'm going to modify it slightly. So we've still got 30 degrees. I'm going to leave that as it is. I no longer have 120. I've got 60. So it's this length that I now need to modify. And if I keep going, then go to here, then there we go. There is our 60 degrees. And I can get rid of that bit now and put A there. And this is going to be Z. So let's take a look at the areas of each, because at the end of the day, that's what we're interested in. We've got the area of S. So the greater one is going to be here, because I've extended it. And this is going to be R. So now, because I've got two of the angles, I've actually got all of the angles. That there is also 30 degrees, and now I can use half AB sine C, because I got two sides, the angle in between. So half times A times root 3A times sine 30. Sine 30 is a half, so I'm going to get root 3A squared over 4. But sorry, I don't know why I called it R, I meant T. And then the area, let me just make that purple. Area of the other one. And now we've got a right angle here. Actually, that makes life really easy because we can just do a half, base times height, half A times root 3A. So root 3A squared over 2. And therefore, what we see when we put these in this ratio is the one on the left is just double the one on the right, which gives us a ratio of 2 to 1. Now, alternatively, you can take it, you can divide through by A squared, root 3 over 2 to root 3 over 4. You can divide through by root 3. You can times through by 4, which again gives us 2 to 1. Right, good question there. Hope you're happy with that. Well done.